Okay, so here we go. Come on, everybody's awake and alert. We're going to plow through some stuff and then we'll do something else. All right, so number 25. Explain why at least 2 students must have the first and the same first and last initial at cathedral. Like I'm LF, I'm not a student, but like I'm LF, there has to be out there somewhere, there doesn't have to be another LF, but there have to be 2 people that match. I was getting panicked. Thank you. These are my erasers. Okay. So, can you explain why there have to be? Well, what, go ahead, what?
Does that have something to do with how many kids are at cathedral?
Yes.
Would that be at the bottom and then two factorial at the top?
No, but you're on the right track. So if we think about first and last initial, if everything goes, how many choices are there for your first initial? 26. How many for your second initial? 26. All right, so how many is that all together? 26 times 26. 676. So what you're telling me is there are only 676 possible combinations. How many kids are at cathedral? Like 1,200, 11 to 1,200, something like that. So wait, there's only 676 possibilities, but there's 11 or 1,200 kids. Doesn't that mean somebody has to match? Right? Now it doesn't mean there's no guarantee that there's another JB, but somebody matches out there because we don't have enough combinations to cover everybody. Would you agree? Okay. I remember when I was a little child, I used to get so excited when somebody had my birthday. I thought that was just the most special thing in the whole wide world that somebody matched my birthday. But really, there's only 365 or 66 possibilities, right, for birthdays. So of course, in the millions of people in the world, somebody's gonna match my birthday, but I just think that was neat. Okay, all right, now the big idea for today. Number 26. I want you to read those 2 questions. I want you to think about, we're choosing 2 people. And I want you to tell me, out of 20, we're choosing 2, if A and B are the same question, or if A and B are different questions. Why are they different, Jared? Because I asked 2 questions?
President and vice president. You can only have, there's one president and one vice president, but you can have 2 people governing the council.
Okay, so he's on the right track. I want you to think about this for a second. If I say I'm going to pick 2 people to be on the council, the governing council, does it matter if I pick Jared first or Jack first? No, they're just going to be on the committee, right? But if I say I'm going to pick a president and a vice president, then does it matter if I pick him first or him first? Yeah, because him president and him vice president is different than him president and his vice president. Do you see that? So for question A, the order that I choose matters. So for question A, order matters. For question B, order does not matter. All right, so that is the big thing that you've got to get. That sometimes when I choose, order matters, and sometimes when I choose, order doesn't matter. If order matters, it's what we call a permutation. And the notation we use for permutations is a P And N stands for the number to choose from. And the R stands for the number chosen. So in this problem, how many people do I have to choose from? 20. How many am I choosing? 2. Now, luckily for you, we can do this on our calculator. So type 20. And then remember how you got the factorial last time? You press math, went across the prob. Now what do you see in the list? Don't you see this in your list? So we've already typed in 20. Now we'll type that button and 2. And the answer should be 380. Is that what you got? Now, the answer to question B is going to be different because it's a different question. Now I'm picking an order doesn't matter. That's called a combination. And the notation is the same, only it's a C. So we have 20 people, we're picking 2 of them, and order doesn't matter. So we're gonna use our combination button. So 20, math, Jack, where's your calculator? Jack, where's your graphic calculator? Okay, so what did we get for that one? 190? Okay, so the calculator's gonna do all the work for you. What is the big decision you have to make? Does order matter? If order matters, we do a P. If order doesn't matter, we do a C. The first number we put in is the total that we have. The second number we put in is the number that we are actually picking. Okay, so let's look at number 27. Okay, number 27. In how many ways can a club with 13 members choose a 4-person leadership team? In how many ways can the club choose a president, vice president, secretary, and treasurer? Okay, so do you recognize that in both problems, we have 13 people, and we're picking 4? So in A, does order matter? No, because I'm just picking a leadership team. So if I pick you 4, it doesn't matter if you're picked first or last. You're part of the team, right? So what is that? That'll be 13C4, because order doesn't matter. I need the combinations of 13 people taken 4 at a time. So 13, math, prob, NCR 4. Did you get 715? Now, what about question B? How many ways can the club choose a president, vice president, secretary, and treasurer? Well, aren't there still 13? And we're still picking 4, but now the order matters. So that's going to be a P. And we type in 13 P 4. Did you get 17,160? Okay. All right. So one more thing I want to actually, no, we can do that later. Let's take a look at our practice quiz now. And this actually, there's 2 of them. the actual quiz will be only 5 questions. This is our practice quiz. All right, so number 1. In how many ways can I arrange 7 books in a row? What? 7 factorial! Now, do we write 7 factorial in the answer blank? No, we type it in on our calculator using the exclamation point. And what is the answer? 5,040? Everybody got it?
Yep.
Perfect. Good work, Jack. All right, number 2. We just talked about this. How many ways can I choose a committee of 6 from a group of 10? Okay, so I got 10. I'm picking 6. Now all I need to decide is
C.
P or C.
Doesn't matter, C.
C. Jack is on fire today. It doesn't matter what order. If it's a committee, I just need to pick 6 people, right? So what does the calculator say when we 10C6? 210? 210. All right. Now we're back to my closet. We were there last week. How many outfits are possible if I have 10 shirts and 11 jumpers? 10 times 11. So 110. 10 times 11. All right, number 4. Now think about this. I'm going to give out a pencil, an eraser, and a calculator. So I'm giving away 3 prizes. I have 8 students. So I have 8 students total, and I'm giving away, I'm going to pick 3 of them to win a prize. Does the order that I pick them matter? Think about this now for a second. Whoa, wait a second. I think the order does matter. Why does the order matter?
Oh, because you're awarding it.
Awarding different prizes. I want you to stop and think about something for a minute, kids. If I'm giving away 3 pencils, right, 3 pencils, do you care if you get picked first, second, or third if you're gonna get a pencil? Heck no. But if I'm giving away a pencil, an eraser, and a calculator, do you care whether you get picked first, second, or third? Yes. If the prizes are different, then doesn't the order matter? If the prizes are all the same, then it doesn't matter. So since these prizes are different, this is gonna be a P. What's AP3?
336.
336? How many letters can you arrange the letters of I love you? Okay, we talked about this last week. What do we start? What do we do first? Count them. How many are there?
8.
8. So we start with 8 factorial. Then what?
And 26. 26
No,
letters.
no 26, Jack.
Oh, no.
There's 2 O's. So Jared says I have to divide by 2 factorial because there's 2 O's. Are there any other duplicates? Nope. So the answer is 8 factorial divided by 2 factorial, 20,160. Right? Jack?
I kind of forgot how that works. Like, I thought if it was like, if you just crossed out, like, 2 O's would be 1.
No. However many O's there are factorial. You divide by whatever number of duplicates you got factorial. So when we did Mississippi, we had whatever, we had 4 of these, so we had 4 factorial, and 4 factorial, and something, I don't know. All of these. Yep.
Because the duplicates. There's like a duplicate.
Okay, you got it?
Yep.
Okay. Now the bonus. How many committees of 3 boys and 2 girls can be chosen from a class with 6 boys and 6 girls? All right, so let's just talk about this for a minute. I have 6 boys and 10 girls. These are my totals. I'm gonna pick 3 boys, and I'm gonna pick 2 girls. Now, I look right here, there's 6 boys, and I'm gonna pick 3 of them. Am I gonna put a P in here or a C in there? I'm making a committee. C. If it's a committee, it doesn't matter. When does it matter? If you're picking a president and a vice president, then it matters. But if you're just picking a team, it doesn't matter. Now, what about the girls? What's that gonna look like?
10,
10.
C2.
Yep, that's exactly what it's gonna look like. I am picking boys and girls, and what did I tell you last week about and means times? I'm picking boys and girls. So I'm gonna do my boys, I'm gonna do my girls, I'm gonna multiply them together. The calculator will do that in one step. You can type 10 C3 times,
I think it's 6.
oh it's crap, 6 C3 times 10 C2 all at once, or you can do them as individual pieces and multiply them together. What do we come up with? 900. Aubrey, you don't have a calculator today either?
Mine's charging, I think it is.
Okay, remember, they're no good to us if they're not charged. All right, okay, flip it over. All right, here we go, number 1, can you do it?
Oh, yeah. 8 factorial.
8
2.
factorial.
Over 2 factorial.
Over 2 factorial, because there's what?
Duplicates, but there's 2 duplicates.
There's 2 what? 2 S's, okay, but look at it carefully.
There's,
Aren't
2
there also
I's.
2 I's?
Yeah.
So you have 2 factorial for the S's, 2 factorial for the I's, and when we do this on our calculator, we divide by both. So 8 factorial divided by 2 factorial divided by 2 factorial. Remember, it's divide, however many divisions you've got. And Phoebe got 10,080.
Yep.
Now, remember a minute ago, I went to my closet and I picked a jumper and a shirt. Well, now I'm going to the pantry and I'm picking a cake mix and a tub of icing. Okay? What's the answer to question number 2? 60. There's 6 ways I can pick a cake. It's like a jumper, only it's a cake this time. And there's 10 ways I can pick a tub of icing. Does that make sense to you guys? All right, how many teams of 4 can be selected from a class of 10? So I have 10, and I'm picking 4. I just need to figure out if I'm gonna use a C or a P. What are your thoughts? Oh, I'm hearing some of each.
C.
Does order matter? Okay, if order doesn't matter, then it's a C. This is a C problem. I'm picking a team of 4. Josh doesn't care if he's picked first or last, he just wants to be on the team, right? Just so he gets picked. How many ways can I arrange 6 people in a row? 6 factorial, which is 720. Make sure you're writing the number down, right? Remember the books on a shelf, people in a row, all the same. How many ways can I choose a president and a treasurer from my class of 22? So kids, you got 22 people, and you're going to pick 2. That would be a P, because I'm picking specific jobs. So order matters. If you're first, you're president. All right, and then this bonus. 5 card hands contain 3 clubs and 2 red. All right, so 3 clubs and that's how I'm gonna multiply 2 red. All right, you gotta know your way around a deck of cards here. It's just something you need to know. You know how a deck of cards works. You got 2 colors, right? Red and black. How many red cards are there in the deck?
21.
52 divided by 2, so it'd be 26. There's 52 cards altogether. Okay, 26 of them are red. I'm going to pick 2 of those red cards. Does the order I pick the cards matter? No, I just need 2 out of the red pile, so that's gonna be 2062. Now, how many clubs are in the deck? Clubs are what color? Black? And the spades are also black? So if there's 26 blacks, and they're divided up into spades and clubs, then there are 13 of each. So we have 13 clubs, and we're picking 3. Again, does the order matter? Nope. So type it in on your calculator, and that is the answer. So 13, 3 times 26. Okay, that is, oh, that was 2062.
92.
All right, I gotta start over because I messed up.
That'll be 92,900.
That's what Phoebe got, and he knows what she's doing. Yep, 92,950?
Yep.
Perfect. So real quick, before we go on, 52 total cards in the deck, right? Split into red and black. Right? Reds are split into diamonds and hearts. So there's 13 of each. And blacks are split into clubs and spades. 13 of each. And then what about the 13 diamonds? What do they look like? If I spread out all my diamonds, what do they look like? 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King, and Ace, right? Those are the 13 cards. When we get to probability, which is going to be soon, you're going to need to have a basic understanding. You don't have to be a card shark. You don't have to know the rules of, poker and all that. No. But you have to be familiar with a deck of cards. All right, so Google it. Yep. Okay, or get a deck out and mess around with it. Okie dokie. So we just took a 10-point quiz and did 2 bonuses. So, and those of you with calculators get a bonus point for that too. Now, we have a quiz tomorrow. I'm counting this as a quiz, okay? But we're also having a quiz tomorrow that's just like this, only 5 questions. It's on a half sheet of paper. Okay. All right, so now we're moving on to the next. Okay. which at first glance, you are going to say, Mrs. Ford, this has absolutely nothing to do with anything that we've been doing. You will see the connection later, but right now we just have a couple foundational things to talk about. So, no writing, right now, no writing, and just watching, okay? Because we gotta make sense of all this. So, if we had a binomial, this is called binomial, x plus y, to the first power, that would just be x plus y. But you know that if we square that, it is not x squared plus y squared, it's a FOIL problem, right? You know that, okay? We're not writing this down, we're just talking about it. This is a FOIL. I know because I FOILed this out zillions of times, that's what you get. If you x plus y, x plus y. Well, what does this mean then? That means x plus y, x plus y, x plus y. So here's two of them. So basically I'd have to take this times another one of these, right? And I know again, because I've done this so many times, that this is what you come up with. All right, so the question says, how do you do x plus y to the 4? Well, we could do it longhand. What does that mean? X plus y, x plus y, x plus y, x plus y, so FOIL, 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 and we get our answer. Luckily, there's a trick. I want you to look at what happened previously and tell me if you have any thoughts on any part of this. Maybe not the whole thing, but any part of it. What do you think? Titus?
The x goes to wherever you're
So this is gonna start with x to the 4th?
and then, x and y is what you want to talk about.
So the next one's gonna be 4.
That y is always squared.
So this is gonna be y to the 4th down here on the end.
Basically, 4x cubed.
This is gonna be 4x cubed with a y.
Plus 4xy.
Here, isn't, what did you say?
4xy cubed.
Now, I agree there's gonna be a 4xy cubed, but I think it's gonna be back here. Because what are you noticing about your exponents? So this one's x cubed, this one's x squared, this one's a plain x, and this one's no x at all.
It's going down.
They're going down. Would you agree? And then what about the y's? On this end, you have a cube, and then a square, and then a first power, and then no y at all? So if we're doing it to the 4th, doesn't it make sense that we're gonna have x to the 4th, just like you said, x cubed? But then don't we need an x squared in here? And then the x and no x. And then what about the y's? 4, 3, darn any y squared here? And there's some number there, but I don't know what it is. But that's what it's gonna look like. Let's make sure you got it. Let's do x plus y to the 5th. I'm not done with this problem. We're not done yet. But let's talk about x plus y to the 5th. How is it going to start? X to the 5th? And isn't it then gonna have an x to the 4th, an x to the 3rd, an x squared, an x, and no x? And then y's are gonna be the same, so you're gonna have a y to the 5th, a y to the 4th, a cube, a square, a plain y, and no y. Does that make sense to everyone? That's what's going to happen every time. The x's are going to count down, and the y's are going to do the same thing from the other end. Now, obviously there's plus signs in here. And now we need the coefficients. Well, you've already made some observations. You make observation, this first one is just 1 every time, right? Just 1. And the last one's 1. And then you observe that the second one appears to be whatever the power is, so that's gonna be a 5 on both ends. It's these ones in the middle, like this one here we were missing, and now we're missing these. Those are the tricky ones. But luckily there's a trick for that too. It's called, well, you can do it with something called the binomial theorem, but it's easier just to use Pascal's triangle. Pascal's triangle. Blaise Pascal was a great mathematician back in the day, long time ago, long time ago. But anyway, his triangle looks like this. It has a 1 and a 1. Now, I'm gonna have to erase some of this, but I want you to notice that, see that 1 and 1 right there? Those are these coefficients. And then 1, 2, 1, see that? And 1, 3, 3, 1. So how did he find those coefficients? Well, he observed the same thing you did. Starts and ends with a 1. Now, this number you know is going to be a 4, but it's going to be a 4 because I add these two together. So this missing one here that I didn't know what it was, what's it going to be? A 6, that's a 6. So then for my 5th row, see 1, 2, 3, 4, 5, my 5th row, I'm going to have a 1 and a 1. And then what's going to go here? 5, 10, 10, 5. So these coefficients are 1, 5, 10, 10 by 1. So if we were doing the 6th one, what would be the coefficients for the 6th row? It starts with a 1, ends with a 1. 6, 15, 20, 15, 6, 1. So we've already observed what's happening with the letters. And then now you know what the numbers are that go in front. So the question was, what's x plus y to the 4th? Right here, this is x plus y to the 4th.
What an answer.
Yeah. No, the directions say expand. Okay. All right, let's look at the next one. Because it's a little bit more complicated, but it's done exactly the same way. So x plus 2y to the 3rd. Now, you have that written down, right? Because I'm going to erase it. Give myself some room here. All right, so let's talk about what we know. We're going to the 3rd power. So look at Pascal's triangle. What is the 3rd row? 1, 3, 3, 1, right?
Yep. Good start.
So start with that. Now, in our last examples, we started here with x to the 3rd, right? We're going to start the same way. So then this one's going to be x to the 2nd. This one's going to be x to the 1st. And this one technically is x to the 0th, which is 1, so you don't even need to write it if you don't want to. But they're counting down. 3, 2, 1, 0. Now, what is the second part of the problem doing? The same thing, but it's going this way, and it's not a plain y, it's a 2y. So we have 2y to the 3rd, 2y to the 2nd, 2y to the 1st, and 2y to the 0th. So in the beginning of things I just erased, my problem was an x plus a y. So those are my two things, x's, y's. Now I have x and 2y. So those are the things that I am putting in each term. Now we'll simplify each term. Can anybody tell me what all of that ends up being?
Just X to the third.
Just x to the third. Just plain old x to the third. Anything to the 0 is just 1. Okay? So this is 1 times 1 times x cubed. Now, what about here? Multiply all that together. What do you get when you times all that together? You get 6 x squared y, 3 times 2 x squared y to the first.
Yep.
Now what do you get here? Be very careful. See this right here? That is 4y squared. Three times 4 is 12 xy squared. This is 4y squared. 3 times 4 xy squared. And what about the last one? Anything to the 0 is 1. So this is just 1. What's that? 8y cubed. All right, are we ready to try the next one?
Mm-hmm.
All right, so look at it. First thing you're gonna do is pick a row of Pascal's triangle. So which row of the triangle are we going to use? 5th row. Now, did we write out the 5th row when we did it before?
Yeah.
Okay, so if we didn't, we'd have to do that, right? We have to figure out what the 5th row is, but we know it's 1, 5, 10, 10, 5, 1. In the beginning examples we did, we had x's and y's. What do we have now? We have 2 x's and negative y's. Those are the 2 parts of your problem. In the original, it was x plus y. So we had an x, we had a y. Now we have 2x and negative y for every term. And if you are tempted to complain about this, remember the alternative. The alternative is to FOIL this out 5 times. That's going to take a lot longer than what we're doing. All right, so let's make sure everybody's clear on the steps. What was step 1? Write down the 5th row of the triangle. What was step 2? Next to each of those numbers, put a this and a this. The only thing left to do is put the exponents on. What exponent is x going to start with? 5. And then it is going to count down. And then what are the y's going to do? They're going to start 5 here and count down this direction. Notice, if you're doing it right, Look at each term. What do the exponents add up to in each term? That will always happen. If you've done it right, that will always happen. I'll add up to this. All right, now we gotta simplify. And we do each term separately. This is a multiplication. All these things are getting times together. Okay? What is anything to the 0? 1. So that's gone, that's gone. So this is all I have left. What's 2 to the 5th? 32. X to the 5th. There we go. Term 1. All right, now what's happening here? Be very careful. You have a 5, but you also have a 2 to the 4th, which is 16. And then you also have a -1. That's a -1 right there. So 5 times 16 times -1. -80. X to the 4th, y. You have x to the 4th, y to the 1st. All right, what's happening here? We have a 10, then we have 2 to the 3rd, 8, and then we have -1 to the 2nd, is 1. So that's going to be 80 x cubed y squared. All right, you see if you can do the last 3. See if you can simplify the last 3. Baby, wake up. Anybody think you got this one right here?
I have it all the way to 31.
1.
What do you have? Yeah, just tell me what you have. We'll see if it's right or not.
1. Go ahead, Doc.
I did 40x squared.
40x squared plus 40x squared
That, I don't know what the line is.
would be y cubed,
So not,
right? Y cubed. But it's also going to be a negative. Why is it going to be negative? Because we have 10 times 4, and then we have -1 cubed. What happens when you cube a negative?
it's their positive.
No.
It's negative.
It's negative, right? So you have 10 times 4 times -1, so -40. And then your x squared, y cubed, they're right there. They're not confusing. They're right there. Anybody get this one? 10 x y to the 4th. Why is that one positive? Because it's negative to the 4th power, which makes it positive. 5 times 2. And then what do you have on the end? -1y to the 5th. I didn't write the 1, but that's what it is. -y to the 5th. Because what happens to this guy? Gone. It's 1. Ignore it. And then you have your -y to the 5th. All right. Couple more and we'll be done.
You got
Okay. All right, so from the indicated terms, so we have 2x plus y to the 11th. Whoa.
Yeah.
if we were expanding this whole thing, stop and think about that for a minute, kids. What's your first power on X? 11, 10, 9, 8. Oh my gosh, this is gonna have, this would be across the whole board. Luckily, we're not doing that. Luckily, we are finding only one specific term in this. So, think about the problem that we just did. I erased it, I'm gonna steal this. So like the problem we just did, we had this. So this right here would be the third term. This was the second term, this was the fourth term, and so on. So we're only finding, thank you, we're only finding one of those terms. Now, every one of the terms has three components. It has a number, I'll call it a coefficient. 1, 5, 10, 10, 5, 1, those are the ones we used last time. It has a power of, in this case, 2x, and a power of y. Every single term, and the whole thing does. Okay? Now, let's see if we can figure out the coefficient. Oh, shoot. Where did I get my coefficients from? Where did I get the 1, 5, 10, 10, 5, 1? Pascal's triangle. Now wait a second. 1, 5, 10, 10, 5, 1. That's the fifth row. Can I do the sixth row? Sure. What would the sixth row be? 1, 6, 15,
20, 15,
6, 1. And could I now do the 7th, then the 8th, then the 9th, then the 10th? Oh my gosh, I really don't want to do that because that's going to be big too, right? Can I do it? Absolutely. I'm going to show you a shortcut. Get your calculator out. And I want you to type 6C3. Got it? Now, I want you to type 6C4. Got it? I want you to type 6C5, 6C6, 6C2, 6C1, 6C0, type them all in, I don't care. Tell me what you notice, if you notice anything about the numbers that you're getting. Leslie's smiling. What do you notice, Leslie?
On
Aren't we getting these numbers? This one right here was 63. This one's 64. This is 65, and this is 66. And I didn't give you much time, but you can do that. So this is 66, 65, 64, 63, 62, 61, 60. So the numbers in the rows of Pascal's triangle are the combination numbers for that row. So if I wanted the 7th row, I would be doing 7C. So if I want the 11th row, I'm going to do the 11C numbers. Okay, let's talk about this. The first number in the 11th row would be 11C11. What would the next number in the 11th row be? 11C10. You got it. Now I want to go down to the 5th one. So 11, 10, 9, 8, 7. Won't it be 11C7? How did I do that? I just counted. 11, 10, 9, 8, 7. Everybody okay?
Mhm.
So the number I want right here is 11C7. It's always gonna be that row, and then whichever one you want, just count down. I want the fifth one, 11, 10, 9, 8, 7. Okay?
And it's in the fifth, so the fifth term, it wouldn't be 5, it would be 7 because you're counting
Counting
backwards.
down from 11. We're counting down from 11. I want the fifth term, and I gotta start with 11. 11, 10, 9, 8, 7. Okay? Now, I'm gonna figure out what that is in a minute, but I gotta put some powers on here. Okay, so think about if we were writing out the whole thing, thank God we're not, but if we were, what would be the power on the X right here? 11. Right? And then it would go down to 10, 11, 10, 9, 8, 7. Isn't that power gonna be the same as I got here when I counted down? And since it's to the 11th power, if that's a 7, this has gotta be a 4. And now we're ready to answer the question. So what's 11C7? It's gonna be big, I have a feeling. Well, 330. Now, I'm multiplying times what? 2 to the 7th, which is 128. So 330 times 128, the answer to your question is right here. Right?
Yeah.
Perfect. Perfect. Okay. We had some show choir people do a great thing. I know it's been a while ago, we just got around to it. But if you would like brownies to celebrate, we got Aubrey and Josh here today. I think that's all of our show choir people. You guys get brownies, they're for you, Aubrey.
Let's go.
You can have one anyway, they're for the class. They're for the
Okay.
class, yeah. They're to celebrate our show choir achievements. No, I mean, I didn't say that.
Well, either way, it's really good press. Do you make them?
Of course I did.
I've been looking forward to this ever since my sister told me about them.
Oh, my.